Hey, we are going to go over integration by parts today. It's integration by parts. The way I like to describe it is that it's kind of like U substitution, but on steroids. Because not only do we have to pick a value for U, we have to pick a second value for the derivative of V. And so a second variable comes in and we have to choose its derivative. So it can be a little bit tough to use sometimes, or tough to identify how to use that. On your guys' assignment for today, all of your stuff is U substitution. And that's where some of this integral stuff can really start to get more complicated, because what do we use? Do we use U substitution? Do we use integration by parts? Do I need to, man, is it some form that's going to turn into like a inverse trig function? And all those things can be like, man, what do I try? And that's a lot of calculus, is kind of trial and error, and to try those things out. So on here, we're just going to go through I'll go through some of the notes here and just kind of explain how does U substitution work. And I'll put the video here in your notes as well once I get done. So integration by parts is essentially the reverse product rule. Let's fix that. It's the reverse product rule. When we're multiplying two things together, it sort of expands out. So we know here that when we take this, U times V, and when we do the derivative of that, right, that's what I mean by the prime, we do that derivative. I'm just kind of breaking this. Well, we do sort of the derivative of the first part and the second part, and we kind of leave those different things. So on here, what we would have, whoops, that moved all over the place on me. All right, so what we would have on here is that this would be U times, let me put that in there, dv, right? We'd take the derivative of one of them, and then we would kind of do the reverse. So v times, keep spelling that wrong, but du, right? Would they get their turns taking on there? And what that sort of means, right? If we do that here, that means we could inverse it, right? We could do the integral of all of this stuff, right? Where here, if we integrate, suppose if we integrate this, we just get back the regular function, U times V. And if we integrate these two things, since it's adding, it doesn't matter the order, we can integrate both of those because we can separate integrals across addition, right? So we have this part. Now what we can do, what we're going to go through in here, is solve for U dv. We're going to solve for that. Essentially, we're going to subtract this away, right? That's what we're going to do. We're going to take this whole section here, and we're going to remove it and subtract it over here, right? That's what we're going to do. We're going to subtract that. And that gives us the formula for integration by parts. It's that easy to figure out. Here's the formula right here. And just to show that a little bit nicer, we'll rearrange it, put the thing in the front. But that is integration by parts. There's the formula, super easy, or so it seems. That's a lot of calculus. It's like, oh yeah, it looks easy, and it's easy to look at the formula, but actually applying the formula can be a little more cumbersome than we want. But so like I said, in here it's a little bit like your U substitution, but on steroids a little bit, because we have to not only choose a value for U in here, right? We not only have to choose a value for U, we also have to choose something for V, and moreover for dv as well. We have to choose something for each of these that we're going to replace stuff with, and I'll show you that in the examples. So I've wrote down here some kind of general guidelines, kind of like for U substitution. A lot of times we try and pick this stuff underneath the square root, or try and pick this stuff on the denominator. But as you guys know, that doesn't always work out perfectly. So these are guidelines. Like, well, they should work out most of the time, sometimes not, right? It's some trial and error at times. So here's an example that we'll go over on this, x times sine x, which before we wouldn't have been able to do this integral on here. So we have to choose, so I've put this structure in here. We have to choose u and dv, and then we have to go backwards and figure out the other two pieces from there. And actually, what I'm going to do, just to make this a little easier on myself, I'm going to go ahead and put this equation, and you could do this in your notes as well, is just write that little equation down in there because I'm going to utilize that. So what I have to choose, I have to choose a u value. And again, my general guidelines say, hey, take a u value that's easy to do the derivative with, which, I'm just going to make that part x. That's this part, which means dv is going to be the rest of this, right? Sine x dx, right? That's going to be my dv. But it's not too bad because now we got to be careful of what direction we're going. Over here, when we find the u's, we're taking the u value and doing its derivative, which the derivative of x is 1, and dx, if you want to put that after it, I'm going to as well because we did the derivative. But when we go this way on the v's, we're going to do the integral of that. We're going opposite. So I need here to do the integral of sine, which is negative cosine of x, right? That's when we do that, that integral on that part. We're basically doing the integral, or the moreover, the antiderivative. And so now we've done this part, we've chosen the thing, so we're going to go equals these different pieces. So now we need to replace these pieces in here. So I'm going to go through and replace these pieces. So I need u times v. So I would look at my thing and I'd say, okay, u times v. So that's negative x cosine of x, right? That's what u times v is. That's right here. And then we would subtract integral of v, which is negative cosine of x, du is 1, so multiplying by 1 doesn't do anything, and then it's 1 dx, so I put that there, right? That is our replacement. This thing is now equal to all of this stuff. And now we can just evaluate the rest of this integral. It's a double negative here, so I'm just going to turn that into being positive. And then we can say, oh, hey, wait a second. The integral of cosine, I know how to do that. The integral of cosine is itself sine of x, right? That's what we have there. And then you can put the plus c in just for good measure and to annoy Adam, because I haven't gotten to do that as much since we don't have class. So as long as we can annoy him, we might as well. So there's our plus c on that part there, but we've taken that. So those are those pieces, and I'll go back and put some squares around there and color those in so that you can identify those as you're working through those. Yeah. So that was our first example. Here's our example 2. Yeah, just showing you some different things that might come up. On this one here, we're going to have to do the integration by parts twice. We're going to do it 2 times over on here. So for the first time here, again, I want to pick something that's fairly easy to do the derivative of, and fairly easy, something that's easy to do an integral of. So you could choose here for the u to be ex, e to the x. That's perfectly fine. I'm going to tell you, though, it's not going to work out super well. So I could choose this to be e to the x, which means that dv would have to be x squared. So when I go to use the integral, it's actually going to make that part worse. If I make this thing x squared, that means the integral for that is going to be x to the 3rd power divided by 3, right? This did not get any better. So that would say to me like, that's maybe not a good choice to use. So maybe down here, I'll put e to the x in this place, and then my u will be x squared. So now I'll try that out. So then this one here, or maybe I'll put my dx, oops, dx after that. So here, we do the derivative of that, which is pretty easy to do the derivative there. Bring the power down. Here it's fairly easy to do the integral of that as well. Right? The integral of e to the x is e to the x. It's not too bad. So now what we do is, again, we'd take this one through. So let's grab my equation so I can follow that along. Again, I usually just have that written like right at the top of the page, so I remember how those pieces go. And so then we just fill those pieces in, right? We should take u times v, which is going to be x squared times e to the x. And then we've got to subtract the integral of v, which is e to the x. I'm going to stick that in there, times du, which is this part, which is 2. So I'm going to put that 2 here, x dx. So I'm going to always put the 2x in front just to format that and look it nice. So that's step one. All right, we did it, we did that. And now it's like, oh, but we have this thing here, right? So in here, maybe we could pull out, we got a 2. Sorry, well, actually, I'll just leave that there. So now the problem is we actually have to do this again, because this, I don't know how to do x and e to the x. So in fact, here, we're going to have to do this process one more time, right? I'm going to have to do this again in this case. Let's make those go away. So in this case here, well, now, okay, so now I'm going to go and do this one. This part we're going to leave because that's all done. So here I'm going to let u be my 2x, which means my du is 2 dx. I'll let my dv be e to the x again, kind of the same thing as what we had before, meaning this will be e to the x. All right, let's make that not be too big. So here we're basically doing the same thing, but on this one. And so now when I go to do this integral here, right, I'm going to pull that out, and it's a little tough to see on that one. But when we take this integral becomes, and I want to make sure I'm going to subtract that whole thing. I think I have it written down here in my notes as well. X times e to the x. And let's go. Let's see where all those pieces came from, right? Again, we're doing this part of the derivative. So, oh, forgot some pieces in there, didn't I? All right, because this should be u times v, so this would be 2ex, and then there should be another 2 in there. So I just forgot a couple of those, forgot my 2 there, my 2 there. So let's make sure we have that in there. We'll get rid of that one. Okay, so forgot those 2's there, didn't I? So in here then, again, where did we get these? U times v, that's right here, u times v. V du right here. Okay, the integral of v du is happening right there. And now we can finish evaluating this. I'm going to make, maybe take this on to the next page here so we can finish evaluating that part. Because we know now, we're subtracting. So I'm going to actually remove that and change this to positive, because if we're subtracting, we can distribute. And then this part here, the integral of e to the x is e to the x. So this is just an extra double of that. So this is just 2 e to the x. That's not too bad. And then again, plus c at the end to go ahead and say, sure, we have a definite integral. If you don't put the plus c, I'm not going to be too mad about that, right? So there we have that whole thing worked out. We had to use that integration by parts twice in there. We had to use it once initially and then again. So if you need to do that on your homework, perfectly fine, copy and paste or do whatever you need to identify that, yeah, you've done that twice. Okay. One last example here. This one's kind of a little bit of a uniqueness on here where we might say, oh man, how do we pick u and dv on this? It doesn't seem like it because it only has one piece, right? So in here, I'm going to let u be the natural log of x because that's not too bad to do the derivative of. We just flip over the inside, which is 1 over x, right? And that's all that is. But what do we make dv? Well, there is actually something left. 1 dx is left here. That's actually okay, right? It's kind of like a placeholder, like multiplying by 1. We don't always put that, which means the integral or the antiderivative of this is x, right? So when we go to fill this in, let's see if I can grab this again here so I can follow my equation here. So in here, our stuff says we should do u times v, so that's x. That's the natural log of x. There's our u times v minus just the integral of v x value. Oh, we don't want any lower bounds. We're just doing an indefinite integral from the low x here, right? That's our v value. And then du is 1 over x. dx, all right? That's where all those pieces are. Now you might identify and you might look at this and say, hey, wait a second, x times 1 over x is the same as 1, which is perfectly fine, and that makes sense. So now we just do the integral of 1, which we've done already in here a little bit, and we just know that the integral of this is x, and then plus c for added effect on there. So it is possible, and it is completely okay at times, and in fact very useful, to let that, be 1, to let your dv be 1. You can do that as well. So there's a few examples on that. I know some of these are a little, can be a little more challenging, and how do you choose those things? So there are 12 questions for your homework there. I want you to give those a try. Should be able to get through some of them. If you have questions on them, let me know. But tomorrow morning, what I'm going to do is I'll release out kind of a hints sheet that will say, hey, here is maybe some stuff that you could choose for you and for DV to make that a little bit easier. So I want you to try it out today, give those a try. And then if you're still kind of struggling with that, check back in under the classroom tab tomorrow, and I will post up a kind of a hints sheet and say, hey, here, try this for you, try this for DV. That might make it a little bit easier there with maybe some other hints on that as well. So again, if you need any help with that stuff, let me know. Otherwise, good luck.